Okay. So, um, some helpful things when we're converting. Okay. So this time we're not, last week we converted points. Okay. So I stopped it at, let's just make sure we can do the conversion of the points. Okay. So this week we're going to convert equations. All right. So we're going to convert a polar to a rectangular equation and a rectangular to a polar equation. Okay. Um, so it's sometimes it helps to plot the point x, y, and decide what quadrant it is, or if it lies on a coordinate axis. Okay. If either x equals 0 or y equals 0, use your sketch to find r. Otherwise, you're going to use r equals the square root of x squared plus y squared. This is just the Pythagorean theorem, right? Last week we talked about it being. Oh, they didn't have to. Where did it go? It was on there somewhere. Oh, right here. It was x squared plus y squared equals r squared. All I did was take the square root of both sides and I solve for r, right? So that's all that this is. It's the repeat of what we had last week. Okay. And then you need to find theta when the point lies. So remember when we're doing theta, it was what? Tangent equals y over x. So in order to reverse that and solve for the theta, we have to take the arctangent. Okay. Um, this is something we've known for a while, that arctangent really only exists in quadrants 1 and 4. However, if we're in 2 or 3, this is something that we'd have to add pi to it. Okay. We'll see if that comes up. I'm not sure that that comes up in this set of notes. I didn't notice it when I was going through, but maybe it does. The basic thing that we have to do here, it's kind of like putting a puzzle together. Okay. Whenever I have an x or a y, I want to turn it into an r and a theta. Okay. Remember last week we had these other little formulas here. Where did they go? Right here. We know that x equals r times cosine theta, y equals r times sine theta. So we're still going to use those. We're still going to use these two. Okay. They just reformatted them in the for what it looks like here. Okay. So if I'm in x's and y's, I want r's and thetas. If I'm in r's and thetas, I want to turn it into x's and y's. And every time I do that, it's going to probably look a little bit different. Okay. So each one of these might look a little bit different, but it's kind of the same. Hopefully you'll start seeing some patterns in the way we put these together. Okay. All right. So we're supposed to convert from rectangular to polar, express the equation in polar form. So anytime I see a y, I'm going to put in an r sine theta. And anytime I see an x, I'm going to put in an r cosine theta. Okay, so I'm going to start there. And then I'm going to try to simplify that for r equals. Okay. All right, so I see a y. I'm putting in r. Oops. My whole machine is being super slow behind me. It's not working as fast as me today. There we go. Not r equals. All right, r sine theta, right? Because y goes with r. Or sorry, y goes with sine. And then I have 1/2 r cosine theta squared. Okay. So I want to get it to r equals. Okay, so I got to get r by itself. The first thing I'm going to do is like distribute that exponent over the r and the cosine. Okay. So r sine theta equals 1/2 r squared cosine squared theta. Remember, the squared is going to go on the cosine, not on the theta. Okay. Then let's see what else I can do with this. I'm going to try to get the r's together, and I'm going to get rid of that fraction. I'm going to do two things at once. Okay. If I want to move this 1/2 to the other side, what do I have to do? Do I divide? Multiply by reciprocal. What's the reciprocal? 2. So I'm going to multiply both sides by 2. So I'm going to get 2. At the same time I'm doing that, I'm also going to divide by r. Okay. So that's going to get rid of the r on the right side. So I'm just left with 2 sine theta equals, the 1/2 is gone because I multiplied by 2, right? What happens with these guys right here? Yeah, I cancel what's left in the top. R cosine squared theta. Okay. All right. So my goal here is to get r by itself. I'm almost there. Okay. How do I move this cosine to the other side? Divide. Good. So I've got 2 sine theta divided by cosine squared theta equals r. Now, you know as well as I do that we typically do not see trig in a denominator. Okay, they like to tend to try to bring it upstairs to a numerator. So we're going to use some of our reciprocal and quotient identities right now to simplify that. Okay, because if it was multiple choice, we would not leave it like that. Okay, so if I split this up, 2 sine theta, I'm going to split up the cosine. Cosine theta times 1 over cosine theta equals r. All right, those should look really familiar. What's sine over cosine equal to? Tangent. So 2 tangent theta and 1 over cosine equals what? Secant theta. Good. Those we did a lot last year, right about this time. That's what I'm teaching right now in trig. So, all right. And that's it on that one. Okay, I've got it into r equals. It's in thetas, no x's and y's anymore, and it's simplified probably as much as we can simplify. Okay. Oh, the next one has a weird trig identity in it. Okay. Let's see how we do on this next one. So, we could leave it. Yeah, we're gonna leave it. All right. So whenever I see an x, what am I supposed to substitute in? Yep, r cosine theta. So I've got r cosine theta squared. And whenever I see a y, what am I supposed to substitute in? R sine theta. Good. All right, you can work on whatever you have to work on for another class, okay? All right. I'm going to try to simplify a little bit as much as I can. This one we're not going to get quite as good as the others, but we're going to do our best. I'm going to go ahead and distribute that squared in. So let's see what happens. We've got 4r squared cosine squared theta times r sine theta equals 1. I'm looking at what they did. They didn't really get it to r equals. They got it to 2r equals, 4r equals. All right. Let's see if we can get our r's together. So what happens when I multiply r squared times r? R cubed. Okay, so we've got 4r cubed cosine squared theta sine theta equals 1. All right, I'm looking at the answer key because that's what I'm working off of right now. They didn't really simplify it more than that. They did not get it into an r equals. They sort of did. Okay, so this is what we could sort of do. Could I take these pieces of trig to the other side? How would I do that? Right now, everything is under what operation? Multiplication. So how do I get it to the other side? Division. Okay. So I'm going to divide that over. So we've got 4r cubed equals 1 over, and I'm going to do 2 1-overs just so you can see it better, and I'm not going to write a million lines of work. Cosine squared theta sine theta. What's 1 over cosine? Secant. So secant squared, and remember, if there's a squared on it, we leave a squared on it. Okay. And then 1 over sine is equal to what? Cosecant theta. All right, if I wanted to, could I take that 4 to the other side and divide by it? Yeah, I could. So that would give me r cubed equals. And at this point, it would depend on kind of what's left. I know what r cubed equals that mess. Could I take the cubed root of both sides if I needed to? Absolutely. I'm not going to because we kind of have it r equals something. But if I really needed to for a multiple choice, I could take the cubed root. Okay? They added another goofy like trig identity, but we're not going to worry about it. It's not going to be, I'm not going to make you do that trig because I don't know that, I can't remember if we did the big trig identities or not last year. I kind of don't think we did. There's another whole set we never went over. All right, we're going to go the other way now. Okay. So we're going to go from polar to rectangular. Okay. These are a little bit, again, everything's going to be a little bit different. These two are much more straightforward. Okay, it's really easy to tell. You substitute something in for y and something in for x. These ones, it's a little bit, the rectangulars is a little bit different every single time. Okay. So the first one says we have to, so we're converting each rectangular and identifying the graph. Support your answer with a polar graphing. We don't necessarily have to do the graphing utility, but if it helps, great. If it doesn't, it's okay. All right, so I need to figure, all I know is that r equals 4, okay? Eventually we'll get into what the pictures of these graphs look like. We haven't quite gotten there yet. So if I know that r equals 4, that means that I'm going to just apply this equation that we have here, okay? I'm going to put 4 in for that r there, and then that should get me something that's in rectangular form, right? An x squared plus y squared equals r squared. So I'm going to write down what I'm using. So I know that x squared plus y squared equals r squared. So I'm going to go ahead and substitute the 4 in for the r. So x squared plus y squared equals 4 squared. What's 4 squared? 16. You have something that is now in rectangular form. And you don't need to solve for x or y. You just need to have x or y in the equation, or x and or y in the equation. Okay? Technically, that's equation of a circle. And so an r equals 4 is a picture of a circle. Okay? All right, looking at B, this one is really, really weird. Okay, so this is one where it's like, okay, that's great. And there's going to be, we're doing one example like it, and then we won't see another one like it. Maybe there'll be one in the assignment. Okay. All right, so I'm going to draw myself a little XY axis so that you can kind of get the idea of what we're trying to picture here. They're saying that theta equals 2 pi over 3. Okay. Well, from our knowledge of unit circle, we know 2 pi over 3 is right here, right? It's a ray coming out of there. In rectangular world, even though my picture doesn't look like it, that's a line, isn't it? Okay, so a line has slope, right? A line equals y equals mx plus b. That's what I'm going for here, even though I haven't used that equation of a line in like 2 years, okay? So basically I need to find a point and I need to find the slope. I could do y minus y1 equals m times x minus x1. I could do that too. That's the equation we've been using this year, okay? Technically, what's my point? What's the point right there? 0, 0. So I have the point. What's the only thing I need to find? Slope. Okay. At 2 pi over 3, we know some stuff about this. Don't we know the coordinates here? So this is the way I'm thinking about this one. So I know that this coordinate is out 0, up 1. So that means that this has to be 1. That has to be square root of 3, right? And they're both over 2. The 1/2 has to be negative. Everybody good with that? Okay. So when I am thinking about this little triangle that's in here, my slope triangle, I know in the x direction I've moved negative 1/2, and in the y direction I've moved square root of 3 over 2. So if I'm thinking about slope, that's rise over run. What's the rise of my triangle? Square root of 3 over 2. Good. What's the run on my triangle? Be negative 1/2. Could we simplify that? Yeah, we could simplify that. What happens with the 2's? They cancel because that's a nice little shortcut. Then we've got square root of 3 over negative 1, which is just going to be negative square root of 3. So I got my slope. It's kind of a weird way to do it, but I got it, right? I used my knowledge of my unit circle and my trig and my algebra skills, right? And I got my slope. I have a point, I have a slope. I could write an equation of a line, right? We've just been calling it an equation of a tangent line all year, but it's an equation of a line. So let's not use this one. Let's use our calculus one, since that's the one we're most familiar with right now. So y minus, what's the y value? 0, right? What's my slope? Negative square root of 3. X minus, what's my x value? Of my point. 0. Did I really need to write all those zeros in there? If I was multiple choice, the answer would look like that, right? Y equals negative square root of 3x. And I have a rectangular equation all of a sudden, right? I got an equation of a line. All right. I think that was kind of the weirdest one of them all, the one you had to kind of really think outside the box on. The rest of them, I think, are not quite as bad. We're going to look for our pattern of our r sine theta and our r cosine theta and try to substitute in for those. So that's kind of the technique we're going to use on these next two. These ones were kind of standalones. These next ones kind of have more patterns in them. Okay. So I have r equals 2 cosecant theta. My goal is to try to find r equals sine or cosine, r times sine or r times cosine theta, because I know that I can substitute x and y in for those things. So I'm going to rewrite cosecant in terms of sine or cosine. So what's another name for cosecant? 1 over sine. Good. Reciprocal identity, right? And you know, if you don't remember them, they're on posted on both sides of the room, right? That's not going to go away. All right, how do I move this to the other side? Multiply. So I've got r sine theta equals 2. Isn't that one of our formulas? What's r times sine theta equal to? Let's go look. We've got it up here in the notes somewhere, don't we? It's r sine theta equal to. It's way up here. I totally run over the top of it, didn't I? All right, it's right here, isn't it? So anytime I see r sine theta, I can substitute in the y. So that's why I was trying to find that, right? If I find that, I know I've got y. All right, so all I'm going to write is y equals 2. It's a horizontal line. Picture of a horizontal line. Okay. The next one uses that concept a little bit. It's not quite as clean. Okay. Sometimes we have to introduce things in order to make things look like what we want them to look like. If I was going to try to recreate, I know I've got cosine. I know if I can get r cosine theta, that I can substitute in an x, right? There isn't a clean way to do that right now. If I move this over to the other side, I now have, don't write this down, just watch me. I'd have r divided by cosine theta, which turns into r secant theta, right? That doesn't help me. I don't know what that is, right? It doesn't translate to x and y. So sometimes mathematicians introduce something to help us write an equation, okay? So in this case, I know that if I get r cosine theta, I am going to be able to get, I'm able to substitute in x. So I'm going to rewrite out this equation. I'm going to leave myself a little bit of space, okay? So leave yourself some space. I'm only rewriting it because there was no space for me. I'm going to introduce an r. If I multiply this side by r, don't I have to also multiply the other side by r? Okay. So this is where it's kind of like we're kind of putting a little bit of a puzzle together. I know I want to introduce an r so I can get rid of the cosine theta. Okay. All right. So now in fact, whatever I do to the right side, I have to do to the left side, right? That's our basic algebra rules since day one of algebra. All right. What's r times r?
R squared.
R squared. Good. And then this is 6r cosine theta, which is great because I know r cosine theta is equal to what? X. Perfect. But the problem is, don't we still have an r that we have to get rid of? Okay, here's the thing though. We know what r squared is, don't we? Go back up and look at this formula. Where is it? Where is it? Right here. What's r squared equal to? What can I sub in for it? I can just stick an x squared plus y. So I'm manipulating that formula again in a different way. Okay, so we know what r squared is. Let's plug in the x squared plus y squared for it. Okay, that's why I'd say it's like a puzzle we're putting together, right? Every time you just got to find the right pieces to substitute in. A lot of algebra is about, stuff like this is about substituting in something that's equivalent. Okay, which that is a perfectly okay equation. We could rewrite it a little bit. We could say that I could put this over to the other side and make it equal to 0. I could go further with it, but it's not something I've ever taught you. We could technically complete the square and make it, it's actually a picture of a circle with radius 3, but we're not going to worry about that part. So just leave it as is. Okay, so once you've got it into x's and y's, I'm going to be happy. Okay. All right. The last one we've got to do today. Okay, notice we're going from, let's see, read the instructions so we can determine which way we're going to go to and from. Read the instructions. All right, do I want this to be in rectangular or polar? I want to go to polar, so I need to add in r's and thetas, right? Right now I'm in x's and y's, okay? So before I try to get this converted, I've got a lot of weird squaring going on there. I'm going to multiply some of that stuff out so that it makes it easier later on, because it's probably easier to manipulate the algebra in x's and y's than it is to manipulate it once I put the trig in there. Not that it can't be done, it totally can. But I'm going to go ahead and FOIL these guys out because, right, doesn't squared mean write it twice, right? And then so we FOIL. So let's write it twice. It's been a while since we've done that. So x minus 3 times x minus 3 plus y minus 2 times y minus 2 equals 13. Okay, so we've got x squared. What do I get in the middle for this guy here? Negative 6, good. Plus 9, perfect. Plus y squared. What's going to go in the middle for this one? And then what's going to go on the last? Plus 4 equals 13. Good. Okay. Let's try to isolate and get just the x's and the y's on the one side. So if I took this, and this to the other side, what's 9 plus 4? 13. If I subtract that to the other side, what happens? They all cancel, don't they? So technically they all go away and I'm equal to 0. Okay, so let's go with that for now. So we've got x squared minus 6x plus y squared minus 4y equals 0. Okay, at this point, I would go with, let's go ahead and try to substitute in. Actually, I'm going to rearrange a little bit before I substitute. I'm going to do one more step here. If I can possibly not have to square a piece of trig, that would be nice, wouldn't it? So just like when we see an x, we automatically go, okay, that's r cosine theta. Look at what else I have if I rearrange this. So if I rearrange it as x squared, I'm going to move this up. I'm going to trade their spots. Plus y squared minus 6x minus 4y equals 0. Okay. What's x squared plus y squared equal to in our new world here?
R squared.
That's r squared. So I could substitute r squared in there, and then I don't have to worry about trying to square a sine or a cosine, right? So that's something I'm looking for now too, is if I can get that x squared plus y squared, I'm going to put in an r squared. It's kind of like when we have sine squared plus cosine squared, we can put in a 1. Okay. All right. I'm going to also now do, let's see, what do I get to put in for x? R cosine. Good. And then what do I get to put in for y? R sine theta. Good. Equals 0. There's a negative there. This looks like an extended 4. All right. Okay. If I was going to try to maybe solve for this, okay, and get r by itself, okay, this is good. This is technically a polar equation, right? I've got it in r's. I've got it in cosines. There is a way, though, to get it into r equals here a little bit. So do you notice any maybe greatest common factors in there? Anybody see a greatest common factor? What's in all three terms? R. So let's pull out that R greatest common factor. So R times R minus 6 cosine theta minus 4 sine theta equals 0. Now, technically, if I wanted this to equal, if I wanted to get it into an R equals equation, I could apply the zero product property, okay, and tear it apart so that R equals 0, or I've got R minus 6 cosine theta minus 4 sine theta equals 0. So write that down. Then we've got to talk about this last thing here, okay? Okay, we're still learning about this. We're going to talk about the graphing part of it. That's the next lesson, is learning how to graph these things a little bit more than just a point. Okay. We're going to learn how to graph a polar equation, not just a polar point. But whenever we have an r equals, that's going to be something that's a circle. All right. If r equals 0, is it making much of a circle, do you think? No. Okay. So what this one really is, you can't have r equal to 0. So this one is kind of like an extraneous solution, right? We don't really get anything from that. So if we could turn this into an r equals, though, okay? So how would I move the 6 cosine theta and the 4 sine theta to the other side? Not dividing. I'm adding. Okay, good. So we're going to have r equals 6 cosine theta. Sorry, I wrote an O instead of what I wanted to write. 6 cosine. What just happened? Oh. That's always good. I don't know what just happened. Oh, I hit. You know what that is? That's Immersive Reader. At least I knew what it was. Okay. I hit a button when I. Yeah, great. Next tip. Thanks. Can I exit out of this, please? We're trying to learn. I know. We're trying to learn. There we go. Exit. Okay. All right. It's a really cool little app, but we don't need it right now. Okay. Cosine theta and then plus 4 sine theta. Okay? All right. I think that's it. I'm not worried about the graphing piece. If when you're looking at the homework assignment and they simplify it more, I think that the answers might have everything on it, like all the steps. They might simplify more into some places that we didn't, just because I chose not to go further with the trig. So it's, as long as you get it into, when you're going to polar, it's in r's and thetas, and when you're going to rectangular, it's in x's and y's, I'm happy. Okay, that's where I want you to be with these equations. Okay. All right, and that's all I've got for you today. I think that there was homework out there. Did I put homework out there? I can't remember. I think that it was out there. I just did one worksheet for the whole thing, right? Probably. I'm going to go look and see what I did, because I don't remember.